Hello, I am Shubhajit Rai from Narula Institute of Technology, Electrical Engineering Department. Today we discuss measurement of capacitance by Sauty Bridge. Our objective is to measure the capacitance of a unknown capacitor by Sauty Bridge. Now, what is Sauty Bridge? De-Sauty bridge is basically used to find the capacitance of the given condenser. The De-Sauty bridge is an AC bridge, works on the principle of Wheatstone bridge. It is used to determine the capacity of an unknown capacitor C2 in terms of a standard known capacitor C1. R1 and R2 are non-inductive resistors. R1, R2, C1, C2 are connected in a Wheatstone bridge. When the bridge balances, the ratio of impedance are equal. This balance can be obtained by varying either R3 or R4. The advantage of this bridge is its simplicity, but this advantage is fulfilled by the fact that it is impossible to obtain balance if both the capacitors are not free from dielectric losses. Thus, with this method, only lossless capacitor like air capacitor can be obtained. Now, let us compare this De-Sauty bridge circuit with a generalized AC bridge circuit. For that, we will draw a generalized AC bridge circuit. Z1, Z2, Z4 and Z3 are the impedance. By comparing the De-Sauty bridge circuit and the AC bridge circuit, we can write from the equation here Z4 equals to R4. Now we know that the balance condition of the AC bridge circuit is Z1 by Z4 equals to Z2 by Z3, and from this equation we can write Z1 Z3 equal to Z2 Z4. On comparison of this equation we write C2, that means unknown capacitor, equals to C3 into R4 by R1. Okay. Now this is the circuit diagram of De-Sauty bridge. Here C2 is the unknown capacitor and C1 is the known capacitor. R1, this is small r1. Small r1, this is dielectric. There is a dielectric loss in the capacitor, and dielectric loss measured by the small resistor R1, and here also R2. There are four resistance R1, R2, R4 and R3. You can see they are all variable. By vary the variable, we can find the value of unknown capacitor, and this is the supply Vs. Okay, this is the total circuit diagram of De-Sauty bridge, and here the millivoltmeter used for find the null point when the bridge is balanced condition. Table, serial number, standard capacitor, given capacitor, R4 and R3. Now this is the calculation part. C2, the unknown capacitor value, equals to C1 into R4 by R1. Put the value from the experiment, calculate the value of the unknown capacitor, and after that we can find the percentage error. Now what is percentage error? Percentage error equals to tested value minus standard value divided by standard value. Here the standard value is the value of the unknown capacitor which we already set, and tested value the value which we get from the experiment. That means the experimental value is our tested value. And this is the virtual lab link. Now we click on the link. This is the virtual lab simulation page. This is measurement of capacitance by De-Sauty bridge, and this is the De-Sauty bridge which we already discussed in our slide. Okay. Now we perform the experiment. First we set the unknown capacitor value, that is C2. we set the value is 0.05, and here we can see the C2 value is already here 0.045 microfarad, and this is a supply switch. Now we on the switch. Here you can see the millivoltmeter is not zero position. For the most accurate value, we vary the variable from here. We can vary also here, but most accurate value we can vary the variable from here. Okay, you can see I vary the variable, and you can see the millivoltmeter movement. Okay, you can see we vary the capacitor value and change here the millivoltmeter reading. Now we set a capacitor value. Okay, now we change it from 3. You can see the millivoltmeter reading is vary. We vary the C, and it automatically change the millivoltmeter reading. The millivoltmeter reading is decreases, and it tends to zero position. When we find the zero or nearest to zero, that means null point, or nearest to null point, that means the bridge is balanced condition, and that time we can find or calculate the unknown capacitor value from the Sauty bridge. The value is decreasing and the capacitor value is increasing, and the value of the millivoltmeter also decreasing, and it tends to reach null point. It's almost reach to null point, the millivoltmeter reading. The millivoltmeter reading is increasing now, so we decrease the capacitor value, and you can see the millivoltmeter reading again decreasing. And this is the closest value of null point. Okay, and this is the variable capacitor value. Now we click on measure capacitor value. Now we click on the simulate and get the unknown capacitor value C2. So C2 value is 0.045 microfarad, and we set the unknown capacitor value from here. We can see 0.045 also. Okay, so now you can see here we set the value C1 is 0.45, and the given capacitor value is also 0.45. So C2 equals to C1 means 0.045 microfarad into R4 by R1 is also 1. So C2 is 0.045 microfarad. We measure the C2, the unknown capacitor value, by this equation. Now the percentage error is also 0 because the tested value and the standard value is same. So the percentage error is 0. So this is the total experiment. Thank you.